Lesson 10-2, Arithmetic Sequences and Series. Use arithmetic sequences, find sums of arithmetic series. Let's take a look at an arithmetic sequence and see how it's tied in to the linear equation, especially point-slope form. We know that our domain and range, domain consists of the counting numbers and the range consists of the numbers in the sequence. We're going to take the first point and we're going to use it for x sub 1, y sub 1. So we're going to put it right into here. And then we're going to take the last point in our domain and range and we're going to put it in here for x and y. So now we have this equation, and what we're going to do is we're going to solve for a sub n. So we're going to take this to the other side, and we have a wonderful equation that relates the term number and the term. So let's take a look at how this is going to help us. So here's the formula and how it's going to help us find the term, the 20th term, because we know the term number. All right, so what we're going to do is we're going to notice that we know a sub 1, which is 3. We do know the difference, and the difference is 7. Looks like we're adding 7 each time. And we do know n, which is 20. We're looking for the 20th term. So let's go ahead and put that all in. We're looking for the 20th term. We know the first term is 3. We know n is 20. 20 take away 1. And we know the difference is 7. And we put all of these in our calculator, and that is going to be 19. 3 plus 19 times 7, and that answer is 136. So we know the 20th term is 136 without us having to go through each term and doing it up to the 20th term. So this saves us some work. Your turn. Here's the answer. Let's take a look at how we would write an equation for the nth term. Again, we're going to be able to use this equation, and it's going to be an equation that helps us create these numbers without us having to go through each term here. So again, what do we know? Well, we know the first term is -8. We know that the difference is 2 because it looks like we're adding 2 to each time. And we don't have an n because we're looking for the nth term, so we're going to continue to use n. So a sub n, we're just looking for a formula. Our first term is -8, and we're going to leave n there, and our difference is 2. So here's a formula that will give you the nth term. Let's clean it up a little bit, and then this answer will be -10 plus 2n. Now this is a formula to create our sequence. So if I put a 1 in here, I am going to get -8. If I put a 2 in here, I'm going to get -6. If I put a 3 in here, I am going to get -4. So it's already creating these first 3. But the advantage to this formula is it can give you the 100th term or the 150th term without you having to go through each number prior to that. Your turn. Here's the answer. Let's go ahead and do it again, write an equation for the nth term, and this is the information we're being given. So let's take a look at what we know and we don't know. We don't know the first term. We do know n is 6, and we know that a sub n is equal to 11, and we also know the difference is -11. So before we can find the equation for the nth term, we really do need this value right here. So let's go ahead and do that. This is 11 equals a sub 1. We're going to keep that there. N is 6. And we know our difference is -11. So this is 11 equals a sub 1 plus, and this is 5 times -11, which is -55. So a sub 1 will be 66. So now we know our a sub 1 term, and now I can write out the formula. A sub n will be equal to 66 plus n minus 1 times, and our difference is -11. Let's clean this up a little bit. 66 minus 11n plus 11. So this answer is going to be 77 minus 11n. So this formula will create our first term, our second term, even our sixth term right here. Your turn. And here's the answer. All right, let's take a look at how we could find numbers in between on an arithmetic sequence. So we know this is our a sub 1 term, a sub 2, a sub 3, a sub 4, a sub 5. So what do we know? Well, we know that the first term is 21. We know n is equal to 5 because that's that number we have, and a sub 5 is equal to 45. And what we don't know is the difference. That's what we don't know. So this formula will help us find it. Let's go ahead and do that. We have 45 equals 21 plus, and we have 5 minus 1d. So we'll be able to find our difference. This will be 24 equals 4d. So d is equal to 6. D is equal to 6. Okay, so now that we know D is equal to 6, we're going to add 6, and that'll be 27. Add 6, and that'll be 33. Add 6, this will be 39. Add 6 will be 44, and we found our 3 numbers. Your turn, and here's the answer. Now let's take a look at a series. And a series is formed when the terms of the sequence are added. An arithmetic series is the sum of the terms in the arithmetic sequence. The sum of the n terms is what we call a partial sum. So we're not going to add to infinity, we're just going to add to a certain number, and that certain number is called S sub n. All right, so here are 2 formulas. S sub n needs the number of terms, the first term and the last term, and then divided by 2. The alternate form is when you know the first term and the difference. So when you know the first term and the difference, you can use this formula right here. All right, let's take a look at how would we find the sums here. So we have the first term and the last term. What we don't know is the number of terms, so that we can't actually use this formula or this formula. But the formula we've just been using about the sequence, so let's take a look at the sequence. The sequence is 8, 12, 16, and 280. With the sequence, we can try to figure out what 80 is. Is it the 20th term? Is it the 14th term? We can use this formula to help us. So we're going to say a sub n, which is 80, equals, our first term is 8, plus, and we don't know how many terms there are, but we know our difference is, it looks like it's going up by 4. So this is going to be 72 is equal to 4n minus 4. 4n equals 76. And so n will be equal to 19. So there are 19 terms. So S of 19 will be equal to 19. And our first term is 8. And our last term is 80, all divided by 2. So this is going to be 19 times 44. And 19 times 44 is 836. So the sum is going to be, if we added all these up, all 19 terms, and we didn't do it the long way, this would be our answer. Your turn. And here's the answer. Let's take a look at finding the first 3 terms of this arithmetic series in which we have this information. So we have the first term, the last term, and the sum. So it looks like we have all of this, and this will help us get us our term number. And if we have our term number, we'll be able to figure out our difference, and our difference will help us figure out how to go about this. So let's go ahead and use the sum formula. So the sum is 129. I'm using this formula right here, is equal to n. We don't know what that is, but we know our first term is 14 plus 29, all divided by 2. So this is 129 equals n, and this is going to be 43 over 2. Now I'm not going to make it a decimal, I'm just going to multiply the other side by the reciprocal. So 2 over 43 times 129, and I notice I can do some reducing. and that tells me that there are 6 terms from a sub 1 to a sub n, which happens to be the 6. So what I'm looking for is the difference. Now I'm going to concentrate on this. This is going to help me find my difference because I know all of these terms. So my a sub 6 term is 29, and my first term is 14. I do know n is 6, and I know my difference is what I'm looking for. So when I subtract these two, that'll be 15 is equal to 5d, and d is equal to 3. So this tells me it's a difference of 3. So we're going to start at 14, and then we're going to add 3, that's 17, and then add 3, and that's 20. And it was asking us for the first 3 terms, and that's what I've done. Your turn. And here's the answer. Let's take a look at some shorthand, which is called sigma notation. Now, we've been talking about a sum of n terms. Another way to write a sum is to use this sigma notation. It's the capital letter. And what we have is we have some indexes. We're going to have this in terms of a letter. You know, function notation uses x, and sigma notation uses other letters. I is a popular one, k is another popular one. So this tells us where our term starts and to the last term that we have. So this is our k equal to 1 term. So when k is equal to 1, we put a 1 in for k right here. This is our second term. We're going to put the number 2 in here into our formula. This is our third term. We're going to put 3 in for k, and on until we put our last number, which is 12. This will be our 12th term, and we're going to be adding all of these. Okay, let's go ahead and take a look at how to do this problem. So we want to evaluate this. Well, let's go ahead and take a look at what we have. We're going to start with k equal to 3. So when we put a 3 in here, we are going to get 2 times 3 plus 1, which is a 7. And our fourth term is going to be, or our 4, k equal to 4, will be 8 plus 1, which is 9. And then we're going to go to 5, and 5 is going to be 10 plus 1, which is 11. So it looks like our terms are going to be like this, looking like this, and then we're going to add until we get to our last term, and that'll be when we put 20 here, and that'll be 21. So these are the numbers that we're trying to add together. That's what the sigma notation is a shortcut for. So we have this thing, and what we want to do is we want to find the sum. Okay, in order to find the sum, we can actually use this formula, the sum formula. I think we have enough information. We're going to be able to figure out how many terms we have. Our first term and our last term are known. Okay, now since we're going from 3, 4, 5, all the way to 10, the question is, how many terms is there? Well, let's go ahead and write them down. 6, 7, 8, 9. So there's 1, 2, 3, 4, 5, 6, 7, 8 terms in this summation. And you can get 8 terms, without me counting, you can do this a lot faster. What you do is you take the number 10 and you subtract 3. That's going to be 7, but then you just add 1 right here. So you just subtract these two numbers and add 1, and that'll be the number of terms. So the sum of the 8 terms will be equal to 8, and our first term is 7. Our last term is 21, all divided by 2. And so when I simplify, that's going to be 112. And there's our answer, 112. Your turn. And here's the answer.